Okay, so let's look at some applications right here. And the first one is a really basic one. It says that a mason is forming a rectangular floor for a storage shed. And the perimeter of this storage shed floor is to be 44 feet. And we want to find out, well, what dimensions will maximize the area? So the first thing we key in on is this key phrase right here of a rectangular floor. So we're going to have a floor that is rectangular in shape somehow. And we want to find out, well, what are the dimensions that are going to maximize this? So this is a job for us identifying some variables. So we'll call the length of this rectangle L and its width W. What do we know about it? Well, we know that the perimeter is 44 feet. What does that mean? Well, perimeter is the entire distance around the figure, and we know that perimeter is always given for a rectangle as 2 times the length plus 2 times the width. So what we do know is that 44 will equal the sum of 2 times L plus 2 times W. But what are we asked to find? Well, we're asked to find what is the maximum area. So we do need a formula for area right here. And area is always given for a rectangle as length times width. Well, the problem with that, of course, is that we have two variables. And we can't have two variables if we're going to be finding a maximum or a minimum. So our goal here is to rewrite that area formula in terms of either L or W. So let's solve for W right here. So I'm going to subtract 2L from both sides of this formula right here. So that 44 minus 2L is equal to 2 times W. But we need W alone right here, because in this formula, if we're going to replace W, we're going to have to isolate it here. So we divide both sides by 2. Every single term gets divided by 2, divide by 2. And we get 22 minus L is equal to W. So anywhere we see W in our area formula, that's what we're going to use. And so our area can be written in terms of the length. So area as a function of length will equal the length L times 22 minus L. Well, rewriting this formula one more time, our formula for area in terms of length is equal to 22L minus L squared. Well, what does that mean to me? Remember, if we were looking for a maximum, in essence what we're doing is that our maximum always occurs on a parabola, on a second degree polynomial like this, at the vertex. And we're looking for the maximum or minimum area at that vertex when we're doing it. So what are we going to do? Well, what we want to do is we want to find the vertex. Right? So from our vertex formula, right, we said that if we had an equation ax squared plus bx plus c, that's our function of x, then the vertex occurs at the point b negative of b over 2 times a and whatever the value of the function at negative b over 2 times a is. All right, so in this case, what does our function say? Well, our function a of L, if I put it in this standard form, is negative 1 times L squared plus 22 times L, and C would be 0, of course, at the very end of that. We don't really usually put that. No, we don't really need it here, so I'll just go ahead and get rid of it. And we're going to say that, well, in this case, then, A is being replaced with negative 1, B with 22, and so our value for L at which this occurs is going to be negative 22 divided by 2 times negative 1, and when you work that through, you're going to get L equals positive 11. So 11 feet is where it occurs, that's going to occur at. And of course, we know what's going to happen next, because if our length is equal to 11 feet, then our width is equal to 22 minus 11 by this formula right here, which is to say that the width is 11 feet. But this shouldn't surprise us. After all, the maximum area occurs inside a square. And in this particular case, the square would have to be 11 by 11 feet to make it work out that way. So our shed floor should be a perfect square of 11 feet per side. Okay, more applications to come in the next videos.